Hi guys, this is Amar and welcome to Network Engineer Stuff. So guys, in this video we'll focus on BGP interview question and answers advanced part 2. So in part 1 guys, we have already seen from question number 1 to question number 4. So we will start with question number 5. Yes. We'll start with this question number 5. So question number 5 says why loopback interface is more preferred over physical interfaces while configuring BGP neighbor. So whenever we are configuring BGP neighborship, we always prefer to use loopback interface and not the physical interface. So what is the reason behind this? So this is a bit a tricky question for interview, and the answer is also guys a bit interesting. So loopback interface guys, you all know that they never go down, right? Because they're logical interfaces. They never go down unless manually shut. Unless until you shut that loopback interface manually, it won't go down. But the physical interface, okay, they will go down if the link fails. Let's say there are two routers, R1 and R2. Okay, there's a link between R1 and R2, and if this link goes down, the physical interface will also go down, which are connecting to that link, right? And which will cause the BGP session. And let's say BGP is configured, BGP session is configured. That BGP session will also drop. It will go down. But if the link fails, the loopback interfaces won't go down. Let's say here is some loopback configured. It won't go down. The reachability between loopback interfaces can be achieved via alternate path, and so the neighborship will remain up. So you can explain this maybe with help of a small topology. I'll show you. Let's say this is R1, R2, R3 and R4. We have some connectivity like this. There's also one link between R1 and R3. And let's say they are in the same AS and some IGP is running. That IGP can be OSPF, EIGRP, anything. And or there may be some static routing. And there are some loopbacks configured. Okay, so let's say for R1 it's 1.1.1.1. For R3, let's say the loopback is 3.3.3.3. Now this loopback will be reachable. This R1 will learn this R3's loopback 3.3.3.3 via some IGP, and it will have multiple paths. R1 will have multiple paths to reach to the R3's loopback. Of course, the one path will be this direct link, the other path will be via R2, and the third path will be via R1, R4, R3. So this will be the three possible paths. Now let's say there is IP which is configured over this interface on R1 13.1.1.1, and for R3 this interface is having IP 13.1.1.2. Now if you configure BGP neighborship between R1 and R3 using physical interface IP address, that is 13.1.1.1 and 13.1.1.2, and in case R1 and R3, the link between R1 and R3 goes down, the BGP neighborship will also go down, because this physical interfaces will go down once the link between R1 and R3 goes down. But in case you use to configure BGP neighborship between R1 and R3, if you use the loopback interfaces 1.1.1.1 and 3.3.3.3, and even if the link between R1 and R3 goes down, the BGP neighborship won't go down, because 1.1.1.1 and 3.3.3.3 are still reachable via these two paths, R1, R2, R3, or via R1, R4, R3, anything. So that is the main reason why loopback interfaces are used while we configure BGP neighborship. There's another reason which I've mentioned over here, that is using loopback reduces BGP session count and simplifies configuration. So it basically reduces BGP sessions. Okay, let's say here is R1 and here is R2. Okay, and we have, let's say, multiple links between R1 and R2. Now these multiple links are there, and let's say we have to configure BGP neighborship between these two routers using the physical interfaces. So what we have to do is we have to configure one BGP neighborship using this link, that is, let's say, link 1, and one BGP neighborship using this link, that is link 2. If you want to achieve that redundancy in the BGP sessions, or in the connectivity for the BGP connectivity, I'll say. So we have to configure, in this case, 2 BGP sessions. So in case of physical, it will be 2 BGP sessions. And let's say if we use a loopback interface, let's say 1.1.1.1, and here we have 2.2.2.2, and let's say if you use the loopback interfaces for the BGP neighborship, we have to configure only one session using this loopback interfaces, right? So this is the advantage, because we have to configure only one BGP session, so the BGP session count goes down, and also it simplifies the configuration. The other advantage would be load balancing and ECMP. So ECMP is equal cost multipath. So let's say these two links, link 1 and link 2, they have same cost, same metric. Okay. So, and if you configure the BGP neighborship between R1 and R2 using loopback interface, fine. So what will happen is that since they have the same cost, this both the links will be used, and we can achieve load balanced. So the traffic will be forwarded from both these links. The traffic will travel between both these links. Okay. So it will basically, we can use both the links. So that is what I've mentioned. When loopbacks are used, IGP has multiple equal cost paths. Traffic towards the loopback can be load balanced. So that is one advantage. The other advantage of using loopbacks over physical interfaces while configuring BGP is the ease of identifying that BGP routers. Okay, once you are using a loopback now, guys who are working uh, in large organizations, or ISPs, they may be aware that how easy it is to identify the routers with its loopback IP. It's an easy job to identify using loopback IPs, rather than identifying the routers with that physical interface IP addresses. So it's easy to identify and troubleshoot the issues. This is the configuration, guys, you have to use whenever you are using loopback interfaces, which we have already discussed in the previous video. You have to use this update source extra command whenever you are using loopback interfaces for BGP neighborship configuration. So guys, question number 6. In below scenario, if EBGP neighbors asked to be configured using loopback interfaces, what additional configuration is required? So guys, these are two routers, R1 and R2. They are in different AS. R1 is in AS 100 and R2 is in AS 200. So they are into different AS. And if we have to configure EBGP neighborship between these two routers using loopback interfaces, okay. So these are the loopback interfaces of the routers, and we have to configure EBGP neighborship between this two routers using loopback interfaces. What additional configuration is required? We already have this configuration, and which is not sufficient, or which is not complete for forming EBGP neighborship. So there's some additional configuration which is required, and why it is required, that is the question. So guys, since we are using loopback, we already have this update source loopback, which is mandatory. And whenever, guys, we are using we are configuring EBGP neighborship between two different routers into different AS, there is a rule. That rule says that EBGP neighbors should be directly connected. That is, they should be in the same subnet. Okay. Now, here we are using loopback interfaces, which are not in the same subnet, right? This 1.1.1.1 and 2.2.2.2, they are not in the same subnet. They are in the different subnet. They are not directly connected to each other. Basically, they are into different broadcast domain itself, right? They are not directly connected to each other. So when we are forming EBGP neighborship using this indirectly connected IPs, what needs to be done is that we will need something in configuration, and that is EBGP multi-hop. Why it is required, I'll tell you. By default, as I told, that this should be in the same subnet. Okay. Now the reason is that by default the behavior is that the TTL value in the BGP packet, TTL value in the BGP packet is 1 when the BGP packet enters from one AS to the another AS. I'll repeat. By default, the TTL value in BGP packet is 1 when it enters from one AS to other AS. So in case we are using loopback interface, okay, in case we are using loopback interface, the BGP packet, when it enters from one AS to another AS, the TTL value will expire because they are not directly connected to each other. The TTL value is only 1 and they are few hop away, right? This IP, this loopback IP and this loopback IP are not directly connected. They are few hops away. So if they're traveling multiple hops to reach each other, of course the TTL value of 1 will expire. So that is the reason why we have to mention this EBGP multi-hop followed by the hop count. So here the hop count, they are like 2 hops away. So whenever we configure this command, this will be configuration of R1 neighbor 2.2.2.2 EBGP multi-hop, that hop count will be 2. Now this value of hop count, it is in the range of 1 to 255. So 1 is default. Okay, that is the reason why we have the TTL value of 1. And in case of loopback, you can use 2. Like here, you can use 2, or maybe you can use more than 2 also. There's no problem. You can use 3, 4, 5 till 255. That is not the problem. So all these things I have mentioned over here, guys. Okay. If you want these notes, guys, please do mail me. I will give you a mail address at the end of the video. I do have a mail address. If you mail me and request me these notes, I can provide you. Question number 7. How does EBGP prevent routing loops? Now, this is a very frequently asked question. How EBGP prevents routing loops? Now, there's a simple answer to this, is that it uses an attribute which is AS path attribute. Okay, so EBGP uses AS path attribute to prevent loops. Now, you can explain again with help of some diagram. Let's say this is router R1, this is router R2, this is router R3. Okay. And all these 3 routers are in different AS. Okay. Now, what happens that whenever R1 advertise some route to R2, it will give that route. In addition to that, it will give few attributes also. And one of the mandatory attribute is AS path. And AS path will have the AS number of router R1. Now, let's say here the AS number is 100. Here, let's say the AS number is 200. Here, let's say the AS number is 300. Okay. So when R2 will have that particular route, it will have that AS path. Let's say the route is of 100.1.1.1/32. So that route of 100.1.1.1/32 will have an AS path in that, which will be, so it will be having some AS path which will be 100. And when R2 forward that same route to R3, it will also add its own AS path number. It will add its own AS number in that AS path. So when it will receive on R3 that route will be there like this, and it will of course have the AS path 100 and it will have 200 also, which R2 adds. And when R3 gives it back to R1, R1 will also get that route, and when it gets that route, it will have the AS path attribute has 100, 200 and also 300, because R3 will also add its own AS number in that AS path attribute. Now, when R1 checks this AS path attribute, it will find that it have its own AS number in that that is 100 in that AS path attribute of the route. So it will discard that particular route itself. So this is how uh, in EBGP uh, AS path attributes helps in preventing the routing loops. It's a very common question, but it's a very important. And if you explain, guys, just with some help of some topology, it will be great. But always remember, AS path is the attribute which helps in EBGP prevent loops. Question number 8. What is the difference between soft and hard reset in BGP? So, when we talk about hard reset and soft reset in BGP, so these are used very frequently. So, guys who are working, they may be aware, they may be frequently using these commands. This commands clear BGP neighbor, and this commands, soft reset out, soft reset in. So hard reset, guys, basically what is this is when you give this command clear IP BGP, mentioning the neighbor IP of that BGP, it basically tears down the BGP session and re-establish it from scratch. Now let's say there are two routers. I'll explain with help again with some topology. Let's say this is two routers, R1 and R2, and let's say the BGP neighborship between them is stuck. For some reason it is stuck. Okay, or you wanted to rebuild the BGP session between R1 and R2, you will give a hard reset. Okay, let's say on R1 you given, this is an engineer, network engineer, so we'll give a hard reset. So once you given hard reset by using the command clear IP BGP followed by the neighbor IP address, what it will do, it will tear down the BGP session. It will bring that BGP session down. Okay, it will break that TCP session. It will bring that BGP session completely down and re-establish it from the scratch. So it will follow that complete FSM. Okay, that all the states, it will go through all that states and then it will come up. Okay, so it is basically used while troubleshooting many a times when your neighborship is stuck. Soft reset. Now, soft reset will not bring the neighborship down. Okay, so it will only resend some BGP updates. So let's say this is R1 and this is R2. So it will only, let's say here, if you issue the command of soft reset, it will only send some updates to R2, its BGP neighbor. Okay, now there are two different commands here, clear IP BGP followed by the neighbor IP, soft in and out. Okay, so it's a little difference between them. So when we issue this command of in, it resends all receive updates from the neighbors. So whatever updates it have from the neighbor, it will resend it to R2. And if you use out, it will resend local BGP updates. So whatever local BGP updates this router will have, that it will send. So in, updates from the neighbor, out, local BGP updates. So that is how it's work. And guys, that soft reset basically we use when when we configure, let's say, some new route map or some filters or policies, and if you wanted to reprocess those routes, resend those routes, we use this soft reset commands. So here is the impact. Okay, what impact it will have, hard reset, soft reset. So the impact is that in hard reset, it drops the BGP session and triggers route withdrawal and re-advertisement. It completely breaks the session. So all the routes are withdrawn and again they are re-advertised. And in soft reset, no the disruption is there in the BGP session. The routes are just refreshed. So and you will use soft reset. So you will use soft reset when you apply a new route map or filter policies and you wanted to reprocess the route. So this is the use case of soft reset. And for hard reset, whenever the BGP neighborship is stuck, you will use this hard reset. So guys, I'll stop here in this video till I think we have covered 4 questions, and I think we'll cover more questions in coming videos. So I'll stop here. Before that, you can contact me, guys, on this particular email address, network engineer stuff @gmail.com. Okay, you can mail me if you want the notes or any help. You can mail me on this particular email address. I will forward you this notes of BGP interviews. And we also do have, if you need the BGP notes completely, I do have. You can I can share those notes also with you. So I'll stop here, but before stopping, I like to request all my subscribers to please like this video, and please do share with your friends basically, and help your friends also for clearing BGP interviews. And do please give an appropriate comments on this videos. So I'll stop. I'll catch up in the next video. Till then, bye. Thanks and have a nice day. Thank you.